easier, and a lot of the newer parts you can only get surface mount. If you're wanting to use any of the newer designs, I've seen radio chips, I've seen pretty much anything you want. On a couple boards I'll show you here, I'm actually using microcontrollers. Some of these are only available in surface mount. There are a few drawbacks. Can't really use surface mount parts directly on breadboards. Now there are several designs to adapt, like a common surface mount packages to a dip or something that is compatible with a breadboard, but it's hard to directly use them. It's hard to use them for dead bug style projects, so you're going to pretty much need to build a board. And they don't always have exposed leads. Some of them have, the packages have the leads just are part of the package, and they're just the bottom side of the package. Those can be trickier to place if you're not careful when you design a board. Here's a few different programs. The last one is one I just recently found. The one I use is CADsoft Eagle. These are all free.
Good price.
Yes. Now they each have their own different limitations. CADsoft probably has the most parts predefined. All of them you can define your own part for if it's not in its library. But it's also the most limited. CADsoft, I can only do a board that's about 3 by 5 is the biggest board I can do for free, and then only double-sided boards.
3 by 5.
3 inches by 5 inches. But the others, I'm not certain of all the limitations of them. Some of them are software. The last one is completely online. Like I said, I just found that one a couple weeks ago. I haven't really played around with it. This one, like I said, this is CADsoft Eagle. This is what I use. This is where I entered a schematic. This is for, I'll pass around a couple boards here. This schematic here is for these purple boards that I'm passing around. I did order those online, and I got 3. Actually, that's for an older version. There's 2 different versions of that board coming around. And what this is on screen, you've got all the parts laid out this way, because I can't get my pointer to work. This part right here is actually the processor. If I had zoomed in before I took this screenshot, you can see it better. Obviously you see some MOSFETs and voltage regulator, connector. All of this is just designs on, I just captured one.
Chris?
Yep.
You don't try and etch these boards yourself?
Not for double-sided, but you'll notice the other board that's coming around is a little white board. That one I did etch myself. I will not etch a double-sided. I can't get the alignment good enough. But yes, you can etch them yourself. And you'll see that, like I said, those little white boards that are coming around, I did etch. I don't, like I said, if you can get your design to work simply enough, single-sided or almost single-sided, like just a jumper or 2 on the other side, you can do single-sided. Now the white boards only take one surface mount part, the other parts are through hole. So I'm not going to demonstrate the other parts today, but I figure most people probably know how to solder through hole parts. But then you go into actually laying out the board. This is what these the purple board looks like on screen. This is the when I'm laying it out. The red is actually the top layer of copper, and the blue is the bottom layer. The green is any pad for a through-hole part or a hole that goes through the board that's plated. Carefully, you can overlap certain parts when you're designing things, so that if you've got different options. Like on this board, I'll show you when I switch over here. I've actually got an option, and you can kind of see it on screen here. I've got two different USB connectors right here for two different kinds of USB connectors if I wanted. And I've also got letters wired so that I can use a USB cable and directly wire it. This is actually for the microprocessor the processor that goes on the board. You'll see how small that is. I'll pass it around. I pass around a board that I've already soldered completely. Let me see if this other one is. One's complete, one's partial. These are an older version of the design that I goofed up a little bit on. You can see on the one. And you can see, if you look on the back side of those boards, there's actually two OR gates right next to each other at the one end that are extremely tiny. I may show you those today. Let's see. A few ways you can do the boards. There's toner transfer is one way of doing do it yourself. You use a laser printer, some copper clad board. You get the toner adhered to the board good, and then you etch it. Pretty simple, pretty cheap option, and it can take you about an hour after you've designed it and printed it to actually having a board that's ready to drill and work with. There's many options. You can go directly to a board house if you're wanting to have a lot of boards. But what the techniques I'm going to show you today are really designed for working with a small number of boards, just one or two. The purple boards I ordered from oshpark.com. They do the boards $5 a square inch for 3 and free shipping to you. And it takes about a week and a half, 2 weeks to get your boards in. And you can see they're nice quality boards. Sometimes you have little bits on the side that you might have to break off just because they take a bunch of people's orders or boards and put them onto one board. So sometimes you got to break those little things off. But if it's not critical, if you got those sticking off, you can leave them as well. The other site is actually a little bit cheaper when you're ordering a lot of boards, but you order in quantities of 10 and you pay shipping. So yeah, it's cheaper per board, and that's for the largest of the boards. That price covers the design limits of the free version of Eagle. There's paid versions that you can do 4-layer or more, you can do boards this size if you want, or bigger, with some of the paid versions. A few of the considerations when you're actually designing it, you want to make sure your boards are clean when you start. So you don't want, if you're using boards that you etch yourself and you make a few of them at a time, you'll notice the white ones I'm passing around still have the toner left on them. That helps protect the copper so that it stays fresh when I etch or when I go to solder to it. I've only cleaned off one of the copper off of one of them. I just use a fine grit sandpaper to get rid of the toner. Your parts, again, for surface mount, you want to make sure you've got clean parts, which pretty much means new or very recently, or somewhat recently ordered, or parts that have been kept in a clean environment. You also, with surface mount, you want to make sure you use flux. I got this container of flux for about $6 at Radio Shack. It'll last a long time. But this flux is paste-based. Sometimes you want liquid. This is the same flux. I just added some 91% rubbing alcohol. And I also have a bottle of rubbing alcohol that I'll use to clean either of those off the boards after soldering, because you do need to make sure you clean them after. You want a decent solder, and by that you want it to be a thin solder. I've got 2 rolls that are the same thing, even though the label's different. I found I like this silver bearing solder, but the more important part of this is it's thin. This is 0.022 inch solder. So very thin. That's actually about the size of some of the leads or larger. But it lets you control how much solder you're using a lot better. And the other thing is moisture. I'm going to open up one of these packs that I will be soldering the parts tonight and show you one thing that they put in here so you know about the moisture. You don't have to worry about this so much on the hobbyist level, but if you're doing a lot of boards, it can become an issue. This is in an airtight package so that the moisture doesn't get in. But you'll find there's a card like this. I'll pass this one around. This tells you how much moisture it is. It gives you an idea how much moisture is in there. That's to know how much the parts have been exposed to. Because if they've been exposed to too much moisture, some methods of cooking them or making the boards, like if I'm using a hot air tool, or some of the more commercial methods such as a reflow oven, can cause an effect called popcorning, which is exactly what it sounds like. Your parts explode like popcorn. And that's never good. This is also a reason you always order spare parts. Few methods I'm going to go through tonight. The first three. I did not bring a toaster oven, obviously. I did not bring a frying pan. The toaster oven is basically a cheap method of doing reflow. There's people that have built controllers for doing that. You can do it without a controller as well. Frying pan's another method people use for doing more boards. I'm going to stick with the soldering iron methods and the hot air tool, and you'll see they get a lot easier as I go down the list, as far as at least the first four. The toaster oven is more of a bulk method. You populate your entire board and do it. The hot air tool you can do part by part, or you can do the whole board. Okay, now let me get this switched over here. Okay. Turn that off because it's just not going to be practical. Okay. Like I said, I've got flux. I've got it in liquid form too, and I always label my bottles. One thing I do keep, this is resistors I've reclaimed in this little container. What I found works better than this though is those cheap paint trays you can get at craft stores that have like 10 little bottles all attached to each other that snap closed because they'll keep your parts from going everywhere. Another thing I forgot to mention during that, you always need some needle nose pliers with these. You do not. These parts are pretty much all too small to handle with your hands to have them work right. All right, need one of the rolls of solder. Okay. These are from the first version of the purple boards. I've made 2 orders already. The first ones I goofed up the design just slightly on one of the parts. All right. Now, there are a couple tools that you'll want to use. No matter what, you need to put the flux on. I like using Q-tips if I'm doing a large area, or toothpicks if I'm just doing small. Let's see, I'm going to... And these same methods can also be used for repair. This is one, I'm having a glitch, so I'm not going to be able to show you these TNCs working tonight because like I said, I'm having a glitch getting the firmware loaded onto them. But show you how these work. I'll show you that one in a moment. I'm going to show first this method. The to the pin by pin and the drag soldering. I'm going to use a little 555 timer IC. This is a this package is an SOIC. Its pinouts for pretty much any SOIC is going to be the same as, if you're familiar with standard dip parts, these pinouts are pretty much almost always going to be the same if the part's available in both packages. You'll notice that if you looked at the pads on the whiteboards as they came around, that's what I'm soldering on for these. I'm going to start by tinning the pads.
Sorry, Chris.
Huh?
Sorry.
Oh, yeah. Oops, forgot to put some flux on there first.
Like working with postage stamps.
Mm-hmm. Yeah.
Don't lick it.
Yeah.
Yeah.
Now the way this works,
Center.
I'm going to zoom out a little bit so you can see what's going on up here. I'm just putting a little bit of solder on there, and I'm going to actually take the solder off. I'm just tinning these because this is board that I etched myself. So I need something, it's a lot easier if you've tinned some of your pads first.
Why is the solder only sticking
For the copper,
to the,
just that's part of the reason you use flux.
really?
The flux actually helps the solder stick to just what you want it to stick to. Solder actually has a lot of surface tension when you put it on, and then you'll actually see that when I do some of the hot air, because one of the parts I'll do is actually a rather large part and does have a pad that you can't really just get to for a soldering iron. I'm going to put this one in place. One of the other things this flux can be used for is actually as a bit of glue, as a bit of temporary glue for your surface mount part to help hold it in place just a little bit. I happen to know the way this part goes on. You want to make sure you line them up properly, of course. And I've got that one lined up. Oops, I'm off the screen there. As you can see, I've got my the legs right on the pads all the way around. Now I'm going to just turn it the other way because I've already put some solder there. And I'm going to start, this one I'm going to do pad by pad on this side. And you'll see these parts do move easily, which is one of the reasons I say a soldering iron is probably not the best option.
Do you have any tip on holding it down, Chris, while you're getting to it? A piece of tape or something? Or?
You can use a little piece of tape, but
Aren't there little weighted things people use for that?
one of the other tricks is to solder one corner and the opposite corner. And then double check that you've got it lined up, which I've got this nice big magnification. I can see I still do. Now I'm going to finish up doing this side this way.
Something that small, how much is a solder bridge problem is there?
Well, that mostly ends up depending on your boards. Now, you think this is small. I'll show you again in a second when I get it smaller.
Mine is a little older than yours.
What's the wattage on the iron?
This particular one is, whoa, I got my soldering iron turned way up. I normally work with it at about 550 to 600 degrees is what I usually have it set for. I just had it over here. Had it up at about 700. Now, like I said, you always want to clean it. I use 91% rubbing alcohol. Rubbing alcohol works just fine. It's one of the other useful things for Q-tips. And you just want to clean it just to get that. All the flux is this is rosin flux, which is designed for working with integrated circuits, but the flux really just is to help make sure everything's clean, and it also helps your solder flow better.
So is 91% alcohol a regular drugstore item?
Yep.
Or is that
Yep. I got the big bottle that I filled this little thing out of. I got at Target for about $4 because I bought the bigger bottle. There's some smaller pitch. This is actually the same microprocessor or microcontroller as you saw on the purple boards. This is just attached to a carrier board. And I didn't really explain the one method, the second method that I used. I'm going to have to sit down. It's just going to be easier for doing this method. I'm going to show you one of the square ones now. These are much finer pitch. I will do one side that way. You'll zoom out here. When you get them in a package like this, you'll see they're just, let's see in there. They're just packaged right in there. And you can see these particular microcontrollers are Freescale microcontrollers. What I'm going to do, I'm going to take this. Now I'll show you a few things to watch for. When you make a board, you want to make sure you put a reference on there. I've got this white dot right here is my reference dot, telling me where my pin 1 should be. That's going to match up with these, that reference dot in the bottom left corner there.
Chris, how sensitive are those to static electricity?
They can be quite sensitive. But you can do a whole board at once when you're soldering these. I don't have all the parts for this board, but oh. I'm just going to be putting on for the parts for that IC right now. But I'm just putting flux on the pads. Oops. And if you get too much, it's not a big deal. Now, a lot of these are not as sensitive as you might think. They are, even though they're sensitive to heat, they're not that bad. Yes, and I forgot to do that. Now, this is where I was saying you can, some of the hot air methods. I'm not going.
You're off center again.
I'm just soldering. Since I fluxed the pads, I'm just putting solder right on the tip of the iron. I'm going to drag it right across those pads. Now, it's a lot easier to use the hot air method, and you'll see how quick that can go, because I can just line it up with a little bit of flux, and I can use a little bit more solder.
You make it look easy, Chris.
Yeah, no bridge is nice.
That's one of the. I just used a little bit of solder, and then you saw how I dragged the soldering iron over. That's one of the things flux helps you with. It keeps your soldering, keeps things clean.
That's great.
Yeah. The first time you use flux after not using it, you'll realize you'll wonder how you ever did the soldering without it. Now I'm just putting some fresh flux over because when you pull it off the roll, that rosin core is your flux if you're like just doing bare wire, but extra flux never hurts. Now, just grab that part. Yep. Just to move it a little in bulk, but you can see how it's really not liking moving right. It's
Yeah, right on
not quite. This row over here is off a little bit. If you're doing it by hand, you need to get these right on, and I can see this side is off a bit as well. Those are pretty good. Not perfect, but they should be good enough. I'm going to solder this one by hand. You'll see these do move. And I'm just remelting that solder. That's all I'm doing, and it's grabbing the pins. Now there's another method. If I hadn't pre-soldered these, there's the here. I'm going to show you on this side here. You can do the solder drag method, where you've got it fluxed nice, and you drag your soldering iron with solder on it right across. But you have to line up your part good. And as you'll see, there are some bridges in there right now. That's where one of the other tricks of this is. If you're using that method, you use solder wick, because you'll solder it first, and then you come back with your solder wick. Carefully get all the solder, well, all the excess solder off, because you do cause bridges when you use that method. Or rather, it's easy to cause bridges using that method, and harder to clean them up. But with practice, that method is somewhat effective. Solder bridges there. Oh, still got a couple.
Chris, is it the temperature you selected that keeps you from barbecuing the board?
It's working with it quick, and actually these boards are pretty durable. As far as the temperatures, it's more of keeping the chip at the parts at a consistent temperature than it is not heating them up too much. You don't want to get a hot spot on the part. Work evenly. Right. I'm going to keep working on this part real quick here, just to get it cleaned up.
So if you get a troublesome area, you might stop and work on another part of the chip?
Right. Or use a different method. which I will be showing you how to. I'll finish this chip with a different method. This is the easier method. This is a $15 hot air tool I got at Crafts 2000. You can get it pretty much any other craft store. The ones that are designed for solder or for working with electronics cost upwards of $200. And really, yes, you get what you pay for. You get a lot more adjustments with them. But for a hobbyist, this one works just fine for doing 1 or 2 boards. The trick with this, I just turn it on and it gets warm. You want to start with it away from your part so that you're warming your part up evenly. And then just come in. You can see how it's spreading that flux. Because I've got it coming pretty much right on top of the chip. See if we can get it
Oh
at a
yeah,
different
I can see it
angle.
spread now.
Have you ever attempted to put the flux on the leads?
You can do that. That's just as effective as putting it on the board. And that can actually help hold your, if you look on, you can actually see that it is soldered down to the board now. And that's the,
On all 4 sides?
yep. Actually, yes. Actually, I missed the one side. I didn't get it heated enough. It did not get the solder heated enough quite on that side of this focus. All right. Shaking it too much.
What's the temperature on that air?
This one, I don't have an adjustment for me to know. But the trick is with air, with the hot air, there are so many variables just from how you hold it that even if you were using one of the fancier tools where you do have those adjustments, how far you're holding it away, how fast it's blowing, all changes everything.
I mean, you actually just gotta kind of look and see when it's melting.
Huh?
See when it's melting the solder, that you know what it's doing, where it's
Yeah, you can see when it's melting it. Okay, that one's in. Okay, now it's soldered. And I can tell just by looking at the edge here, I can see it in the, it's hard to see on that camera, but I can see it up close. See, the board is a little warm.
So that gives you a cleaner.
Yes, it actually helps you line things up better too. I'll show you on the other side a part that is a bit more, it's a larger part, but it'll show this better. I'm going to tin the, this is going to be the voltage regulator. It goes on this set of pads right here, and you see this huge pad? That's the ground lead. I'm going to just put a little bit of flux on there.
And the heat sink.
Huh?
And the heat sink.
Yes, the heat sink for the ground lead. And I'm just going to tin it real quick. You don't need to use too much solder. Let me just get that part. Let's see, is that's Sorry, I brought a bunch of different parts for these boards here. I think it's this one. Yes. These are 3.3 volt regulators, and as you see, there's that card in here. I normally tape these back shut so that I don't have to deal with the moisture as much. Now, it does say to bake them, but not that big of an issue. Here is my strip of parts. I got 3 of them left in there, and you see they're pretty big compared to some of the other parts. I've soldered that. It has cooled some. I'm going to put some flux on there. And let me just get one of these out. This one I'm going to do completely hot air.
Chris, is there a way you can elevate one of those lamps because your hands are casting a shadow on the board? Thank you. If that doesn't mess things up for you.
No. And if you notice, the part's not even straight. It's just close. I'm going to use hot air. First, I'm just warming that part up. Like I said, you don't want to overheat the parts. So I'm warming the part and the board. The solder, you can see it melting. I told you this one would be a lot more. This one would be a lot more. That is one of the really nice things about hot air. Your parts will, if your pads are made good, your parts will line up really nice. If you just tin them, like I said, I'm just using regular solder. If you're doing a lot of boards, you want to use the solder paste, which is basically your flux with some tiny solder balls built right into it. But if you're just doing a small number of boards, you've probably already got solder. Like I said, I like this solder. It works really good. And one of the other advantages of the 6036-2 is it melts and solidifies at the same temperature. Unlike the 6040 where you've got that goofy molten state, this doesn't have it, which means if I bump that part, that solder's solid. I could have bumped it right after I took the heat away. As long as the solder started to solidify, it was solid. It was not going to move. That's useful even if you're using through hole or just soldering wires.
You don't get that cold solder joint from
Right.
moving.
It pretty much eliminates the chance of cold solder joints. And one of the things about soldering surface mount parts, if you see, notice I'm doing things that you would not, that are completely wrong if you're soldering through hole parts. But you can't do them the way you would do a through hole part because you can't get a soldering iron on one side and solder fed in from the other because you don't have the room. So surface mount does rely on doing everything else right. But that's why you always use flux.
Have you tried the stuff in a syringe? Does you notice a difference, or?
I have some of the stuff in a syringe. I've not used it because it's so thick it's hard to get out by hand. And you pretty much need a needle to apply it. Or if you're doing a lot of boards, the other way it's used, instead of in a syringe, sometimes it comes in a tub, like this container of flux did. And you squeeze. That's also used for squeegeeing it on with a mask. Usually stainless steel, cut out to match up with your pads. I was just showing you integrated circuits so far. There are also LEDs and other parts.
Whose flux are you using there? I think you said it once, but I
This
didn't write
one
it down.
is
Yeah.
Radio Shack flux. It's the only flux you get from Radio Shack.
64.02.
Yep. And then the liquid is the same stuff, just diluted down with rubbing alcohol. You can use the weaker rubbing alcohol if you want, but I find this the denser stuff helps dissolve things better. I'm going to just clean this board up really quick. It is easier to clean these boards fresh than later.
You're off center here.
I'm just cleaning it. I'm just.
Oh, well, we don't want to miss a thing.
These squeeze bottles I also got at a craft store. They work great for this stuff. Look in the paint section. The other side.
What's the theory behind your project? It's just a Bluetooth.
This project here is a Bluetooth TNC. I don't know how many have Android phones, but there's an application for an Android phone that lets you use APRS right from your Android phone, and it can either go out through the internet, it can use or through the iGate system, or you can use its sound interface, or it can use a TNC based on that runs on Bluetooth. This particular one I used the designs for the Open Tracker from Argent Data. It's an open source TNC, and I included space on the board where I actually put two different ones to put a GPS right on board for this particular one. Like I said, this particular board I designed to have two different USB ports you can use. The smaller set of pads that's out here is for the either a mini or a micro USB port, like you'd find on your cell phone, or a standard USB-B connector, which was on the one of the boards I passed around earlier. Yep, that board. So you can use either depending on what connectors you decide to order. A lot of times when you're ordering the parts, the mini USB or micro USB connectors are actually cheaper. But I figure it's easy to throw both versions on there at the same time and have the board made. That's why I also threw two different GPS modules on here, one on each side of the board. And I only use one. You'll find a lot of circuit boards are that way. They've got, if you ever open up something you bought, you'll see there's a lot of parts, open spots on the circuit board. They designed it so they can throw other functions in there or use a different set of parts, depending on what's available. These also I designed, if you notice there's this 4-pin header. If I chose not to populate GPS at all, I move a transistor and a resistor, and I've got a serial port there that the GPS would use. I've got another one over here that goes in place of the Bluetooth module on the bottom. The Bluetooth module, let me see if I threw those in here. I think I did. I might not have. I don't see it. The Bluetooth module, if you look at that board, there's one on here. That would just sit, it's supposed to sit right on the board. I goofed up on the layout of this first board. Put it on screen here. That's this module here, this green module. And like I said, I goofed up, so I had to carefully adjust so that that would work. That sits right here. R1 and this transistor are completely blocked by using it. But if I don't put the Bluetooth module there, I can put the resistor and that transistor in, and now this port works. Those are actually the same resistor and transistor that would go over here, R2 and Q4, for using the Bluetooth module. Because I need to do a level conversion one way or the other, because the firmware that goes in the microcontroller is expecting the port to be wired a certain way. And the Bluetooth module puts it up the opposite way. Just needs some level conversions. Right?
Now, is this a standard size board? Is that why you're having these space problems?
Actually, the board just happens to be the size that I made it. No, actually, I designed them covered up like that intentionally, so that if I'm using one, I cannot put the parts in to use the other. It blocks it because they're going to electrically conflict. So that's really, you can save space by doing it. It also can help you make your, when you design a board that you can be using a different way. Like I said, these, I got 3 boards. So
you're preventing yourself from making a mistake.
right, it's always helpful to throw things that you don't think you need. Like, I made a mistake on the first board here. One of the other mistakes, I forgot to throw any capacitors next to that crystal if I need them. On the new version, though they're on the underside of the board, they're there. That's what these 2 sets of pads right here are for. If I don't end up needing the capacitors, I don't have to put anything there. But if I do, I don't have to figure out, okay, oh shoot, how am I going to get that there?
So your design software gives you the flexibility of moving these things around?
You can, I'll load up the software real quick over here. Can't see where I'm at. This is the main window for the program. I'm just going to go under Projects, Eagle. Oops, that's a different one. And I'll open up the board. It actually opens up both the schematic and the board so that I can switch back, because any changes to parts I can do right on screen here. And I'll zoom in a bit, you'll be able to see a bit better. This is how I do, like I wanted overlapping parts. I'll show you ones that I did overlapping. The USB ports. Right here, I've got, this is the mini USB connector, and this is the full-size USB connector. I just put the 2 parts right next to each other in the schematic, so they're both in the schematic, but if I don't want one, I just don't fill it. If they're wired properly, then I go to the board and I overlap them on the board. I'll zoom in on that area of the board. They're zooming on the board here. Now, right now, you don't see as much of the blue and the red right now because I did what's called a fill, which I can make it fill in real quick. When I first load the project, it doesn't show that, which actually makes it a little easier to see. And so my grounds aren't necessarily all routed. That's all ground, which is just to help reduce noise. It also helps some of the parts work a little better. But you can see I've got the big USB connector stacked right on the mini USB. And I could put text in that prints on the silk screen right here, as you saw on the board. That's how I managed to put it. These diodes, I actually, when you place them, I'll select a part here real quick. I'm just going to grab this one. And if you notice, right there, these tell you which side of the board it's putting it on. This part is technically placed on, this diode is technically placed on the bottom of the board, but I can put it on the top just as easily. I placed it on the bottom of the board, that way the silk screen printed on the bottom of the board, and I could use that space for some other labeling when I have these boards made.
Does your software warn you when you get these interferences?
Which interferences of like my
Part covering a silk screen?
No, it doesn't warn you of that, because it'll actually, your silk screen, most board houses will automatically cut your silk screen so that it's not covering a pad that you need to solder. Because it does, there's another layer that I don't even turn on, that's the solder mask layer. And that's everything on these boards that was purple is the solder mask. I don't even bother turning that layer on because it automatically does. The green is your parts. There's actually another layer called the cream layer, which is if you're actually doing a lot of boards, the same board. It's what you send out to have the mask for the solder paste made.
Is the purple part what's covering the tracers?
Yes. Yep, that's the solder mask. That also helps keep the solder right to where you want it. And it also helps the board house reduce some cost because the solder mask is a lot cheaper than, well, these boards happen to be gold plated. Which helps, like I said, it helped earlier, the parts need to be clean, including the boards. Having those gold plated helps keep them clean until you're ready to use them. And it does make it a little bit easier to solder with, especially if you're using some of the other processes, or using the non-lead solders. I recommend using a lead-based solder. It's a lot easier to work with. It's lower temperature.
Have you found, or do you use any simulation software?
It's been a long time since I've used simulation software. One sec. I'll let you take this one, Lee.
Oh no. Hey,
So when the board comes from the producer, you don't have to worry about continuity of any tracers?
Generally, they're tested. These, I don't recall if they tested these or not, but I always make my traces big enough I don't really have to worry about it. There is something called a design check that you do in your software. I show you that real quick.
okay. Tawa ka na.
Actually,
Oh, yeah.
it's easier to just type in this program. It's just easier to type DRC, which stands for Design Rule Check. And this is the place I order the boards from. They actually provided the script, so you can actually check it against their policy. But if you're going through somewhere else, you've got the layers. This is the requirements for the layers. The clearance, how far apart things have to be. Distances from edges. And holes. The minimum sizes of a trace. And all of this. And you just hit check. And there's a couple that I specifically not worried about because I designed them that way. Like this one right here. All you do with this error screen, I can double click on something and it goes right to it. Like this one right here. It's telling me I've got 2 drills two drill holes too close together, which can be a problem if the board house doesn't like it. But the reason it's complaining about these is they're overlapping. The two GPS modules take a different size hole, and I did not bother editing the part so that one of them did not take a hole under it. And I just centered the overlap. That's how the two GPS modules are lined up to each other. Right here, it's complaining, I'm double clicking on these. It's complaining about two traces overlapping. One of them doesn't have a name, or I didn't name what trace it, or what circuit it is, so it's not a big deal. Really about the same place. It's actually technically another separate overlap. It's complaining that a trace is too small. It's not one I care about. Same thing here.
So at that overlap, they're not electrically connected?
That overlap, well, on the board they are, but I'm looking at this and I can see, I'll even zoom in a little more for you, that it's just a circle drawn on top of the trace. I don't care about that circle, if that's connected or not. So I can actually, I say, oh, I see what that one is. I don't care about it, so I'll approve it. I'll approve that. I'll approve the width of those because it's saying, hey, those are too narrow for the board. Same thing on that one. And I'll approve the drill distance. So it doesn't even worry about those. Zoom back out here a bit. And you can even run traces. Oops. Get to the bottom scroll bar. Like if you look right in here, I ran a trace right between the two pads on this. In certain surface mount parts, you might be able to get away with soldering a smaller part onto the pads. I've done that on one board. I'll switch back over here. Yeah, on this one here, if you look, I used 1206 is the size of these parts, most of these surface mount resistors here. This one is a part I scavenged though. It's a smaller part. I don't know what size it is. I actually scavenged it off that large circuit board I showed you. And it's just, I haven't soldered this particular board completely. It was a pain in the butt, but that's also why over here you can see how much of a mess it is by these two OR gates. This one, oops. No, it's this one. This one. Sorry, the boards at a glance look the same. This one I used hot air soldering for most of the parts, and you can see how much cleaner it looks, which actually ends up better for the boards as well. Right around there. And you can see on this one, another capacitor that is a lot smaller than the pads that it's designed to take. And you can see how those snap into place. If you want to see it, I'll show you how to solder that small of a part. Find the right board here. I've got one board left that needs those. It's this one. I'm just going to put a blob of flux, and I put way too big of a blob of flux. And I'm going to tin the pads. And you'll see even those can be done. And this is one of the other places that if I used a soldering iron to solder these, the part's going to stick to my soldering iron because of the solder, because of the surface tension of the solder. Put a bit more flux on there. Find those parts. Actually, I think I passed that around a little. I have a strip of parts. When did that come up here? The black strip. Find it up here. Not this. It'd be a strip that looks like this one.
Rub on the floor.
Someone turn the lights on real quick. These parts are very easy to lose. Luckily, most of them are cheap. Don't see them. Can't find those parts. Well, I'll show you the transistor because I do have the transistors right here. They're not quite as small, but the same idea applies. That's going to be this set of pads right here. Always want a clean soldering iron tip. You can see it sort of right in there. You can see how shiny they are. Easy way to open these packages is with a pair of diagonal cutters. Especially for these smaller parts. I'm just cutting the edge of the pack of the carrier open. These are called, this type of pack way they come to you is called cut tape. Comes on a reel as well if you're ordering that many of the part. Sometimes it's easier to turn your board when you're placing these, but you can place multiple parts and do multiple at once. There. I was just getting it in place. You can see that frame's lined up on the pad. It's actually a little high, but I'm going to use the hot air. I'll come in from an angle here. And you'll see it'll get cold. Just like that one before.
Is that writing the part number or the size of part?
I'm sorry?
The writing on that, is that the part number or the size of the part?
That writing is actually an identifier for the part. It is not the part number. These parts are so small, they can't fit the whole part number on there. This part happens to be a 2N7002 transistor.
You don't want to just chuck these in your parts box then?
I'm sorry?
Oh, you don't want to just chuck these in your parts box then?
Right, you pretty much want to know what they are when you order them, but you can get a pretty good idea. Okay. And you can see it's lined up now, and I just had to tap it a little bit. Sometimes you have to do that with these small parts because it was only touching one of the pads when I started. And I'll just clean that one up really quick. And yes, the board is still warm. That's why you're seeing the alcohol boil off. Of course, you can do the or do an LED for you real quick, just to show you how those come out. Now, because there's a few things you've got to look for. There will be some marking on LEDs and any other directional part. Just open one up here. This one has two ways you can identify it. You can identify what way it needs to go. I haven't opened up the package, I just cut off the tape, but on the back side, this is the back side of it right now, you can see there's a side that's all green and a side that has a couple notches on it. That's just so you can identify what way it goes. Also on the front side, I'm going to open it up because you'll be able to see it clearer. Actually, I'll show you one that's already soldered. Right here, I don't know if you can see it. Let me zoom in more. It's getting flooded too much. I think there might be too much light on it. There's a little.
That position your finger was in, did it?
Not that one of them.
Dim it a little bit here. You can see how there's that little green dot on the side of it, on the right side.
Just barely.
Yeah, it's hard to see in this light. It's actually somewhat hard to see anyway. It's easier to see the markings on the back, but that's one other way you can tell what way. In this case, that goes towards the crown. I'll even show you doing a couple parts of it. Just going to flux the one that I'm doing. I'm just doing the red LED. I don't have the green opened up. And the associated resistor. Oops. That's in my soldering iron, and then I'll pull that on the side. I could use a little more solder for those pieces. When doing it this way, I just want a little bit of a bubble of solder on top of those, just so that it's covering the pad so good, because the part's going to sit and use that solder. Okay. Place the LED. Carefully. As I mentioned, sometimes toothpicks can come in handy.
We can't see what you're.
Oops. I'm working on getting the LED off here. And lined up close to its pads. Like I said, it doesn't need to be perfect.
We saw a little bit on.
But it's close. You'll see it fixes itself. Now to find the resistors. Those were 102. Got more of those. In this container, I don't have any more in here. Because of what I know, this one is not that critical.
Checking the LED.
Yeah, it's just the current limiting resistor for the LED. 131, the way these numbers work is actually very similar to the color codes on your through-hole resistors. As far as their meaning, except for there's actual, you don't have to remember colors. It's an actual number. I need to clean the tips of this real quick. There's flux in that on it. That's why the parts are sticking so much. Take a second here. Place this one. And it's tap over just a little bit with the toothpick. Now, I'm going to use hot air to solder that. It's going to be a lot easier. you'll see when they are ready. See the resistor pop in place, and there goes the LED. That is one of the really nice things about this, and that's why I say these tend to be actually easier. And you can see I could have done the whole board if I wanted to fill all the parts. Right there.
Chris, thank you.
Any other questions?
How long did it take you to learn?
First I looked up, well, I was wanting to do some parts that I knew I could only get in surface mount. The first time I did it, I actually figured out I figured out some of the tricks and realized, well, the first one I tried doing was with the soldering iron and realized this is not going to work, especially when I got to those little 5-pin OR gates that were the same size as that transistor I showed you.
Do you use the camera board in your work?
No, actually Chuck brought that for me.
That's just
For tonight, yes.
So many hours do you have into designing the PCB?
In this one, probably took me about an hour to load the schematic and just lay out the board for the first one. And then it was probably maybe 20 minutes of rework for the second board.
Oh, nice.
So, with the capacity,
Well, actually, it would work with 6042 as well. That's on That's on. No,